This lesson is on simplifying radicals. Before we begin simplifying radicals, we need to take note of two important properties. First of all, if we have a positive number a, then the square root of a times a is equal to a. Now that's a real important property and we're going to have to remember it. So, for example, the square root of 3 times 3 is equal to the square root of 9, because 3 times 3 is 9. Well, what is the square root of 9? It's 3. So we see here that the square root of 3 times 3 is 3, and therefore we can kind of glean from that that the square root of a times a will be a, anytime a is a positive number. Another important property that we're going to have to use and we're going to have to know is that if a and b are positive numbers, then the square root of ab is the square root of a times the square root of b. Okay? And so we can kind of separate them like that. If they're both factors of the input of the square root, we can separate them. And just to show you an example of that in practice, we know that the square root of 100 is 10. We can probably do that in our head, because since 10 times 10 is 100, then the square root of 100 is 10. But to show you that we're allowed to break it apart like that, let's do it. We know that 100 is 25 times 4, so the square root of 100 is equal to the square root of 25 times 4. Well, what we're saying is that since these two are both positive numbers, we can break them apart like this. Call it the square root of 25 times the square root of 4. Well, the square root of 25 is 5, and the square root of 4 is 2, and 5 times 2 is 10. So we see that it actually works. So we see that these two really important properties are true. Okay, so these two properties together combine to give us a method for simplifying radicals. What we want to do is to determine factors of the quantity under the radical sign, and if a factor appears twice, then it can be moved outside. So in other words, if we factor out the number under the radical sign and we get the same number appearing twice under the radical sign, we can move it outside. Okay, so let's put it into practice. Suppose we were asked to simplify the square root of 28. Well, we go to this cloud here and we can do some rough work. We know that 28 is 4 times 7, and we know that 4 times 7 can be written as 2 times 2 times 7. So 28 factors down to 2 times 2 times 7. Well, that's like saying then that the square root of 28 is equal to the square root of 2 times 2 times 7. Now, we know we can break it apart, so instead of saying one square root, we can call it two different square roots. We saw that on the last page, so we can call it the square root of 2 times 2 times the square root of 7. But like we said, if you have the same number as a factor appearing twice under the square root sign, you can pull it outside. The square root of 2 times 2 is 2. The square root of 7 remains the square root of 7. Okay? So we broke 28 into its factors. We then took these two factors, put them under one square root, kept the multiplication, put that factor under another square root. We remember the rule that if you have the same factor twice under a square root, you can pull it outside, and you have 2 root 7. Okay, another one then that we're going to do is this really long one. We've got 5 root 72 minus root 75 plus 2 root 50 minus the square root of 192. Well, we're going to do some work on each one of these. Let's begin with the square root of 72. We see that 72 is equal to 8 times 9. Well, 8 is 2 times 2 times 2, and 9 is 3 times 3. So we can say that the square root of 72 is really just the square root of 2 times 2 times 2 times 3 times 3. Well, we've got the 2 appearing twice, so we pull it outside. And we've got the 3 appearing twice, we pull it outside. And we're left with this 2 right here, which is we can't pull outside because there's only one of them. And so now what we've got, these guys become a 2 outside, these guys become a 3 outside, and this guy stays inside. So we have 2 outside times 3 outside times the square root of 2, where the 2 is inside. Well, what's 2 times 3? It's 6. And we keep the square root of 2 inside, so what we've really got is 6 root 2. So the square root of 72 equals 6 root 2. Okay, and then we're going to put that in when we get back to our question. The square root of 72 is 6 root 2, so 5 root 72 will be 5 times 6 root 2. Okay, well, the next one we had to deal with in our question was, sorry getting messed up here, was the square root of 75. Let's simplify that guy. Well, we know that 75 is 25 times 3. 25 is 5 times 5. So 75 is really 5 times 5 times 3. That means the root of 75 is the root of 5 times 5 times 3. Okay, well, we have 2 factors the same underneath the square root sign. We can pull it out. So instead of root 5 times 5 times 3, it's a 5 on the outside and a root 3 on the inside. These 2 guys are on the outside, so you can make that on the, these 2 guys are on the inside and they're the same, so you can put that on the outside. And this guy's alone on the inside, so it has to stay there. So, since root 75 is 5 root 3, when we go back to our question, we'll put a 5 root 3 in for the root of 75. Okay, well next we have to figure out what root 50 is. So let's figure out how to factor 50. 50 is 25 times 2. Well, that's the same as 5 times 5 times 2. That means the square root of 50 is the square root of 5 times 5 times 2. Well, we've got 2 5s under the square root sign, so we're going to pull it out as 1. And we've got a 2 all by itself under the square root sign, so it stays there. So the root of 50 is 5 root 2. So when we go back to simplify the question that we have, we've got 2 root 50. That'll be the same as 2 times 5 root 2. And finally, we have to deal with the root of 192. We're going to do that by factoring 192 itself. 192 is 48 times 4, which is 12 times 4 times 4. Well, 12 is 3 times 4, so we've got 3 times 4 times 4 times 4. But we realize these 4's can all factor down. So what we've got is 3 times 2 times 2 times 2 times 2 times 2 times 2. So the square root of 292 is the square root of 3 times 2 times 2 times 2 times 2 times 2 times 2. Well, these 2 2's on the inside become this 2 on the outside. These 2 2's on the inside become this 2 on the outside. These 2 2's on the inside become this 2 on the outside. And that 3, which is alone as a 3 on the inside, becomes this guy staying on the inside. On the outside we've got 2 times 2 times 2, which is 8, and so we've got 8 root 3. So the square root of 192 is 8 root 3. Square root of 192 is 8 root 3. So to recap, we found that root 72 is 6 root 2, which means 5 root 72 is 5 times 6 root 2. Root 75 is 5 root 3. Root 50 is 5 root 2, so 2 root 50 is 2 times 5 root 2. And root 192 is 8 root 3. So 5 times 6 root 2 is 30 root 2. This stays like it is. 2 times 5 root 2 is 10 root 2. And 8 root 3 stays like it is. And now we go to collect like terms. No different really than if these were variables. We've got 4 terms, 1, 2, 3, and 4. And we see that this term is in terms of a root 2 and a root 2. They're considered like terms, and we're going to collect them. 30 root 2 plus 10 root 2 is simply 40 root 2. Just like if it was 30x plus 10x, we'd call it 40x. Well, 30 root 2 plus 10 root 2 is 40 root 2. And negative 5 root 3 minus 8 root 3, think of it as if they were y's. Negative 5y minus 8y would be negative 13y. So the same thing with root 3's. Negative 5 root 3 minus 8 root 3 is negative 13 root 3. And we've simplified it to something with no like terms, and we're done. Okay, moving to our next question here. We want to evaluate the square root of 784. Well, we'll figure out what 784 equals. 784 is 196 times 4. 196 is 49 times 4. 49 is 7 times 7. So really, 784 breaks down to 7 times 7 times 4 times 4. Well, that means that the square root of 784 is the square root of 7 times 7 times 4 times 4. Well, we've got this 7 appearing twice on the inside, so now it appears once on the outside. We've got these 4's appearing twice on the inside, so now it appears once on the outside. And this is like a division step. So when you're crossing out these factors on the inside, you're leaving behind 1's. So what's left behind is a square root of 1. We don't leave behind a square root of 0 or square root of an empty space. We leave behind square root of 1. So when we pull this 7 out and we pull this 4 out, we're left with the square root of 1. Well, 7 times 4 is 28 times the square root of 1. What is the square root of 1? Square root of 1 is 1. So we're left with 28 times 1, which is 28. So in other words, the square root of 784 is 28. And if you check on your calculator, that's true. And we did it without using a calculator because we know how to simplify radicals. Okay, now our next question is pretty neat. We want to simplify the square root of 96 minus the square root of 6 all over the square root of 54. Well, let's simplify 96. 96 is the same as 16 times 6. 16 times 6 is the same as 4 times 4 times 6. So 96 is 4 times 4 times 6, which means root 96 is root 4 times 4 times 6. Take these 4's that are both inside and factors and put one of them on the outside. That 6 stays alone on the inside. So the root of 96 is 4 root 6. Now, the root of 6 stays the same, okay? And the root of 54 we have to deal with. So let's factor 54. 54 is 9 times 6. 9 is 3 times 3. So really 54 is 3 times 3 times 6. That means root 54 is root 3 times 3 times 6. And since we've got two 3's on the outside, on the inside, we're going to have 1 3 on the outside. And we've got 1 6 on the inside, so we leave it there. And we've got 3 root 6. So root 96 is really 4 root 6. Root 6 is still root 6. Root 54 is 3 root 6. So when we put all that information together, we see root 96 minus root 6 over root 54 becomes 4 root 6 minus root 6 over 3 root 6. Collecting our like terms in the numerator, 4 root 6 minus 1 root 6 is the same as 3 root 6. So 3 root 6 is the numerator, 3 root 6 is the denominator. And when you've got the numerator and denominator of a fraction equaling each other, that fraction is equal to 1.